Okay, we're looking at question 3. State the domain and the range of each relation. Is each relation a function? Justify your answer. Okay, so let's look at A. And don't write in your textbook. Domain is equal to, basically here's a set. It's 5, 6, 7, 8, and 9. That's our domain. And our range is basically 5, 6, 7, 8, and 9. And now, can I get a 5 pointing to anything other than a 5? Nope. Can I get a 6 pointing to anything but a 6? No, no, and no. Can I get a 7 pointing to anything except a 7? No, there's an 8. There's an 8. Can I get a function pointing to anything other than an 8? Sorry, an 8 in the x position, pointing to anything other than an 8? The answer is no. And the 9 uniquely passes only to a 9. Therefore, this relation is a function. Let's look at B. B, 3 points to -1, 4 points to -1, 5 points to -1, and 6 points to -1. Now they're all pointing to -1, but the fact of the matter is they can point to the same thing. Okay? That's like drawing this out and saying 3 points to -1, 2, 3, 4 points to -1, 5, and 6 points to -1. Now, is it a function? Yes, it is. Why is it a function? Because there's only one value. For every x value in the domain, we only have one value. And it passes the vertical line test, to be honest. There's only one value. Okay? But what is the domain? The domain in this case, domain is a set of x values such that it's 3, 4, 5, and 6. That's a domain. And the range is very easy, -1. So even though there's only one value, that they all point to one value, they're allowed to all point to one value. The problem is when the same x value points to two different places. That's what we can't have. Okay, so let's do B. Let's do B. So this was a function, this was a function. Let's do this. Here I have 1, and I have 1. 1 points to 6, and 1 points to 14. And actually 1 points to 11, and 1 points to 8, and 1 points to 0. So it's like this function can't make up its mind. If I give it 1, it's going to tell me 6, -14, 11, -8, or 0. Therefore, it's not a function. So it defies the definition of a function. Now, the domain in this case, the domain is 1. And the range is a set of numbers. What is it? It's 6, -14. It's 11. It's -8. And it's 0. And that is a domain of range of C. Let's look some more. Delete it. Okay, let's see. We are looking now at D. 1 points to 5. Do I have another 1 anywhere else? No, I don't. Do I have another 4 anywhere else pointing to anything other than 11? No. Do I have a 3 pointing to anything else? No, I don't. Do I have a 5 pointing to anything else? No. And an 11 pointing to anything else. So this is a function. Every x value points to a unique y value. Now, you might say, oh, never mind. Yeah, this is definitely a function. And it's actually, Not even close. It's a function. There's no tricks in it. The domain is 1, 5. Let's draw this out nicely. not 5. 1, 4, 3, 5, and 11. And the range, looks like the range, it almost seems like it's the same. Oops. It's 5, right? It's all these y values. 5, 11, 9, 1, and 4. Okay. Last question. Last question is this a function? Well, 3 points to 2 and 3 points to -2. So it's not a function automatically. 2 points to 1 and 2 points to -1. So not a function. All right, but let's do the domain and range anyway, because a relation can have a domain and range. So domain is 3, 2, and 1. I don't have to write 2 and 3 again. Okay, it's all my x values. What's my range? My range, 2, 1, 0, 2, 1, 0, -1, -2. That's my range. And that's how you do question 3.